Yeah, started recording. So today basically we are going to do a system design of Zoom or so there are few concepts that I wanted to cover while we are doing this system design, right? The first thing that I wanted to cover is also something that I have myself not been able to cover for so long, so I decided to study these things up. Okay, someone is joining. Okay. So basically it's like a system design of Zoom, right? So there are different protocols in place, different ways that we do a system design of Zoom. And I think we already we already did this exercise using WebSocket to understand how that works, right? WebRTC is also something similar, uh, but it's actually being used, and we'll see that why it gets used, right? So right, so we'll start, basically try to understand if this is a computer, right? Like this is a person, right, on a computer, let's say, and this is another person on a computer, right? Both of them have opened up Mac on their device, right? So firstly, do any of you know what a protocol is? Hello? Like HTTP protocol, REST protocol, do you guys know what that is, right?
There's basically set of rules from which basically cross-check it. Mm,
Exactly. So a protocol is basically, see, when I and someone else is going to communicate, like I am communicating with you, so I know English and Hindi, you know probably English and some other language, right? So I can communicate to you in Hindi, but you wouldn't understand maybe because you don't know Hindi, right? So we set up this protocol that we are going to communicate in uh, English, right? We are going to communicate in English only, so that's one of the reason. So all of us in this group have this protocol that we are going to communicate in English only. So similarly, all these computers, hardware, all the devices across the world, they have the protocol that they are going to communicate in HTTP, right? In HTTP or HTTPS, HTTP, right? So like last day we did a basic exercise in WebSocket, right? And in the group a lot of you sent the screenshots, right? So if you see that what happened when you hit localhost 8080, what was it showing you?
it was showing some upgrade required.
Exactly, upgrade required. So why was it showing that? So you were hitting it in localhost 8080 with a which is an HTTP connection, right? And it supports WebSockets, right? So what WebSocket is, it's an upgrade over HTTP, right? So like you want to communicate in Hindi, but to talk to me you need to know English also. So when I am talking to you in English, you are saying that, hey, I want to talk to you in Hindi, right? So if I talk to you in English, you are saying upgrade required. Okay, please talk to me in Hindi, right? So that's how WebSocket works, right? So that's the basic, it's an upgrade on HTTP, right? And using that tool that I showed you, right, WS or something, you are basically upgrading your HTTP connection to use WebSocket, right? So I'm not going to do this exercise again, but that was the purpose why I wanted you to do, to understand exactly how WebSocket is used for two-way communication, right? So very basic brief about what how that connection worked, right? This user A and B, they are both communicating on HTTP, right? So if user A wants to communicate to B, right? So if A wants to communicate, just a minute. Yeah, if A wants to communicate with B using WebSocket, right? So what A is first going to do is A is first going to send an upgrade request, right? That, okay, I want to communicate in WebSocket. So B needs to acknowledge that request, right? So let's say you don't know Hindi, so you're going to you won't be able to acknowledge it, but the server that we spin up here, he has WebSocket, right? It knows both English and Hindi, so it's going to acknowledge that request, and then A and B will have a WebSocket connection, right? A and B has a WebSocket connection. Then what is basically a WebSocket connection? It's a long connection that is basically open, within which both A and B can, so there's a central server out there, and then between A and B both can send a request, right? So the server can, so this is the server, this is the client, right? And there can be multiple clients. So the server can send a request to the client, also the client can send a request to the server, as opposed to HTTP where only the client can initiate the request, right? And there are multiple ways in which WebSockets are terminated. One is if let's say the client closes, right? Client closes its connection, then the connection lives on the server for a certain period of time before the server sees that, okay, I haven't received anything yet, let me poll and see if this is alive. Then it polls and sees it's dead, so it closes the connection. Otherwise, the client usually sends a end connection request to the server, and that's how WebSocket ends, right? uh, okay. There's a good reason we're talking this, right? WebRTC is a P2P. We'll come to this later, right? So basically, we will try to understand how something like Zoom or Google Meet works, right? So this is a user. Again, we basically just start from, this is a person. He wants to communicate with Zoom or Google Meet, right? So what are the various services that we create? I think we already did this many times, right? What is the first service that someone who wants to that has Zoom or Google Meet will open up?
User.
Yeah, user service, right? But Zoom or Google Meet works without the user service also. It can be done by anyone, right? uh, okay. User service is used for managing the user metadata, for login and stuff. For Zoom or Google Meet, it's not that important, right? The major purpose of Zoom or Google Meet is to create temporary meeting rooms, right? Temporary meeting rooms where, where users can come, where people can communicate, right? This is the why I'm saying this is the main purpose, because this is where interviewers are, whenever someone wants you to design Zoom or Google Meet, right? What they basically want to know is this part, right? Your understanding of architecture, which one to choose, what to design, right? These services are not that important when it's Zoom or Google Meet, right? Then when we think of it, right, all the other services, what happens? One is the meeting service, right? This is a service through which, you are creating meetings, managing all those meeting information and stuff like that, right? So if you have noticed, right, something like in Google Meet, I created this meeting, right? I created this meeting and I let all of you guys in, right? When I close this meeting, I'm dropping off from the meeting, right? After that, let's say someone is joining the meeting also, the meeting is going on, right? It's not like when I close this meeting, the meeting ends, you hit the link, you get a 404 or something like that, right? So what if I just one day went around and created meeting after meeting after meeting, and I created 1,000 meetings? Do you think that when there is nobody in the meeting is going on? Hello?
I think so. No. No.
Yeah, so basically what happens is when there are 0 people in the meeting, right, is also an important point. So see, this is from, you are seeing, so this is also part of a functional or non-functional requirement, right? When there are 0 people in the meeting, it should just be an entry in a database or something like that, right? It shouldn't be that there is some, persistent connection that is established, there is some server that has spun up that meeting and it's keeping that meeting, right? And then it's not terminating the meeting, right? That's how the architecture should be, that when there is zero people in the meeting, it's basically just there's a database in this meeting service, right? Database, there's a database in this meeting service. When there is zero people in this meeting, this database should be a short this meeting id should be a short url in the meeting service, right? So let's try to understand how this meeting service, right? At the end of it, Google Meet is just a meeting service where you can hold these group meetings or single meeting, right? Let's now isolate things like chat. Okay, right now we are not going to talk about any other feature, right? Not going to talk about any other feature, we're just going to talk about meeting, right? So let's just say when user creates a meeting, what happens is, when user creates a meeting, right? Meeting id is created in the meeting service, right? Now if this user wants to join this meeting id, right? So my meeting service checks the database, it checks for the meeting id, and then it sees that okay, the meeting is not there. So what it's going to do is it's going to create a meeting, right? So what the user does, it continuously polls the meeting service, right? Now there are multiple ways in which the user can connect. He can rest or long polling. What the user does is, there's a stream, right? There's a stream or screen, right? Let's say meeting screen, right? Sorry about this. So this is a meeting screen, right? This is a meeting screen or stream. So this is what this user is, this meeting service is to send to this user, right? When there is just one user located, when there is just one user in the meeting, this stream will have one user. But at the end of it, to think of it, right, we already did system design of Hotstar, Netflix. So just think of it like this user is basically getting this feed back, right? He's also sending his own feed, right? He is sending his own feed down to the meeting service, and he's getting back this feed, right? Does this make sense? Hello, is there anything someone didn't understand? Yeah. Okay, yeah. So I hope it makes sense. But basically, this user is sending his own stream feed down to the meeting service. He's getting this in return. Multiple ways he can do this. Okay, A is long polling, right? Long polling is what he is basically sending the data packet, he's sending his own data packet down to the meeting service, and in response he's getting this stream, right? Or he keeps polling the meeting service for getting back this stream, right? If he is not sending any data also, he keeps polling the meeting service for let's just say there's an endpoint slash feed stream, right? Slash stream, which gives him back this video in chunks and chunks, right? He continues to poll it for 1,000,000 times, and he keeps getting back this stream in chunks, right? So there are certain disadvantages with this approach. Firstly, it's never used, there's a lot of lag, right? How many times can you keep polling this, right, for information, right? Lags are there, and there are other issues also, that HTTP is a small protocol. It's not that suited for video streaming, right? So it's going to cause you a lot of lags and delay. In general, this long polling is not used, right? Long polling is, again, you're doing this over TCP connections, right? Okay, one question: if you were to build a real-time video service, right, would you use TCP or UDP? We already UDP, right? Yeah, why would you use UDP?
because it is fast than TCP and the main difference I'm not remembering, but yes, we'll use UDP.
Yeah, yeah. I'm really happy you got that. So we already discussed this. TCP is basically creates a three-way handshake and it transfers information very slow. There is a server in TCP that continuously checks that if all the packets are reaching in the right order or not, and if the packet has not reached, it will resend the packet. Right, when there is a real-time video communication that's happening, you don't need to get back the packet. Right, UDP is basically just pushes out the packets. Continuously, right, and UDP just pushes out the packets continuously. If you don't get a packet, you don't get a packet, right? That's how video streams happen, that it might buffer or chop out at times, but you won't be needing all the packets, right? You don't need the stale information. But TCP UDP is not used just for the streaming part. If there is like files that you are transferring over call, those or messages you are sending, that will use TCP, right? But anyways, this is long polling. Okay, one of the ways that this could happen, right? It polls. B is you can use WebSocket. So what WebSocket does is this meeting service is going to create a WebSocket connection. So to this, right, to this client, it's also going to create a WebSocket connection to all four of them, right? Let's say there are four people in the meeting, so there will be a WebSocket connection created with all four of them, right? And then this WebSocket, once this WebSocket connection is open, what this does is it continuously sends a stream to these people, right? And these people are sending their feed down to this meeting service, right? That's a way to do this, right? And that's actually a correct way to do this. An alternative, something which we call WebRTC. Yeah, Shweta, you raised your hand.
Yeah, so I have a question that user service will have user registered and will be polling the message according to the meeting ID, right?
Yeah, yeah. So user service is, if you notice them, yeah, user service will just have the user metadata, right? It's the most common thing in all service. But we are not discussing, we are not going into chats and stuff right now. Right now, I want you to focus just on the meeting service, right? So I'll go back. This meeting is, so there are four people. There's WebSocket connections that are created with these four people. They are all getting back this stream, which they are converting in their source device, and then that's how you are seeing the communication, right? So could you tell me what we are going to use to send these streams to these people? This guy could be in India. He is probably in US, Germany. How do you make sure that the streams are legit, like fast and all that stuff? We already discussed this, right? This is a video stream, so it's a large amount of file, large chunk of file, right? We use CDNs, right?
Okay, okay.
Yeah, so CDNs are globally distributed that are able to handle this kind of file. So we basically just send the CDN chunk to the CDN that's nearby to him, and then basically, so the WebSocket connection can also be established with the CDN itself. This person establishes the connection with the CDN nearest to him, and then all those CDNs have established WebSocket connections with this basic meeting service server, right? Now I want you to understand a bit about this WebRTC. What is this? Because this is what actually is being used by Google Meet, Zoom, and everyone, right? So if A and B both are communicating with each other, right? uh, if we talk about WebSocket, what WebSocket does is A is going to send the video feed to user service. You guys, all of you guys did this exercise, right? What was happening? You established a connection with this server and the client and the two clients, right? And then whenever you were sending something in one client, it was appearing in other client, right? So how do you think that was of working behind the scenes?
Maybe the message is coming to the server first, and then server is basically broadcasting it to all
Exactly.
the connected users.
Exactly. If you see this code here, right, broadcast a message for all clients except the sender. So the server handles everything, right? So the server basically manages everything for you. So in turn, there's a lot of load on the server. If there are a million people who are communicating, the server needs to do processes for all of them, right? And for video, it's a lot. So what WebRTC did is it's peer to peer, right? This is a peer, this is a peer. So what it does is the WebRTC is basically like a referee. So the server is still there in WebRTC, server acts like a referee, right? So what happens is this is A and this is B, right? So now think of how IP addresses work, right? So A has an IP address. If you hit IP config on your device, you will get an IP address, but that's its private IP address, right? What happens is we connect to the internet through our router, right? Through the router that you have at home or through a dongle or something like that. So that router creates a public IP address for you, right? Which and inside that router there are instruction sets written which map your private IP address to a public IP address. So whenever that information on the internet, right, whenever you are polling google.com and you are getting back an IP address, right, that like when you're going to google.com wants to send you an information, that's going to send it to your public IP address, and that information hits your router. That router sees that okay, this is the public IP address, it's going to go to your table and find out your private IP address, and then it forwards that information down to your private IP address, which is to your device, right? So as a user, as you know, this computer, it does not know its IP address, right? Does that make sense?
Yes.
Yeah, so it does not know its public IP address. But now you are saying that you communicate directly with him. He doesn't know his own IP address. He doesn't know his own IP address. So he is going to send his private IP address, and that information will not go anywhere, right? So they need to know their own IP address first before they can, you know, communicate. So what they do is they hit this server, and this server lets them gets them back with the IP, with their private IP addresses, right? And then the server basically establishes a kind of connection in between them, right? And where they are able to send a packet to each other's IP address. So while the server is establishing all this connection, is establishing all the protocols, right, the data the data that is being flown through, right, what do you say, the video feed, right, that never touches the server. The video feed is going from here to here, here to here, right? That is how WebRTC will work for two people, right? It's super convenient, right? Data is flowing from here to here. Only the signaling, or if the IP address of this guy changes, he is again going to hit and say, hey, this is my new IP address, let him know. He is going to let him know, and that's how the communication is going to happen in WebRTC. So very low intensity on the server, right? Browser to browser direct communication. Does it make sense? I'm guessing it does. But let's just say if now there are more than two people, right, 3-4 people, right, and you are no longer going to be two stream feed, right? It's a 4 stream feed like this one, right? How do you think this will work?
First sending to server and then to users.
Could be, but
Everybody's private IP will be known to each other.
yeah, so yeah, totally can happen. Okay, that is one way, which is called a mesh, right? What a mesh does is this server is still going to manage everything, but now there are 4 users, right? So what happens is A is going to broadcast his IP address to these 3 people, right? It's going to send the data feed. So A has a data feed, it's going to send to B, C, D. A new person joins. Now A is sending to 5 people. There's 100 people meeting, so everyone is sending their video feed to 100 people, right? Could you imagine the upstream and downstream kind of latency that kind of system will have, right? it's huge, right? Everyone sending to 100, it's going to crash at more than 20 or 25, but up to 5 people, you can assume that this WebRTC architecture will work very well, right? A is sending to its data feed to 5, and then they're interpreting it on the go, right? But beyond that, what we have to do is use something like SFP, which is very similar to WebSocket, where which is WebRTC but with the server, right? So this is a server. All these users are going to send their data feed down to this server, and what the server does, it's going to aggregate all this data feed and make this stream, and it's going to send it back to each and every client, right? So that's how Google can, let's say, handle a size of 100 people meeting or 200, 500 people meeting, right? So this SFP is being used by almost all, but until up to a certain, let's say, 1 2, or right now, let's just say we are 11 people, right, in this meeting, right? So maybe we are using a P2P connection right now, right? Because it's just 11 people. Maybe this stream that I'm making, right, that my device itself is broadcasting to all of your devices, and whatever stream that you guys are making, that is being, so you guys are not making any kind of stream. Sometimes you guys are unmuting yourself and making audio. That audio is getting broadcasted to each of, if other people, right? So that the 11 people in the meeting, if one of you is making an audio, that is being broadcast to the remaining 10 people, right? So that's how I am guessing that right now our system is working. It's working P2P, but if there are 100 people in the meeting, it will turn to SFP, right? So this thing is very clear, right? Hello?
Yeah, the
Yeah.
SFP part, I mean, little confused.
Okay, so SFP is simply WebRTC, but instead of, so WebSocket, you got it? How WebSockets work? Okay, I'll explain it again. But SFP is basically, see, you have a feed, right? Like I am showing my screen. This is a feed, right? And what it's doing is, this Google Meet has a server. So this feed I am sending to the Google Meet server, right? And let's just say that right now none of you is communicating, but let's say, Shweta, you are communicating right now. You are also saying something. So your video is also going to the Google Meet server. Shyam is talking right now, so his video is also going to the Google Meet server. What Google Meet is doing is, it's aggregating all of that. It's aggregating all of that information on the fly, and it's creating this stream, this basically result, that each and every one of you is seeing a result right now, right? Of whatever you are seeing, that is Google Meet is doing that, and it's sending it back to each and every one of your devices, right?
Yes,
This part is clear, right? So this is,
right.
yeah, this is kind of the gist of, what your meeting service is going to be. And this is basically 90%. If you are asked for system design, Zoom or Google Meet, if you say this, you can assume you're done with the interview. But we are going to go a bit more detail, understand a bit more about, what this kind of meeting services work, right? There's something I can think of is chat service. So when you're on a Google Meet like thing, there's something like chat also happening, right? When you're sending chat messages. So you might also send out large files, right? During the chat, right? I can post a file here. So what it can do is, basically, when you're let's say chatting with each other, it's that chat message basically goes, let's just assume it uses TCP protocol, right? So it goes to the user, it establishes your identity and gets a user ID. It hits the chat service where it's stored in the database, and then it hits the meeting ID with like, there's a chat room, right, where it's basically being pushed up, right? And everyone else is basically just polling that. Long polling is a good example here, right? Basically you're long polling and seeing, because chat is something you don't need to see maybe every second. You are long polling, and you're getting all the chats, right? We files also a similar thing. We already explained using CDN, right? How files are getting distributed. Maybe you get a link that redirects to your nearby CDN, and you can get that file, right? So a smart way this will be done is, this user is in India, this is in US, this is a specific location. So your your service can figure out exactly where these users are. It will figure out exactly where those CDNs are, and it's going to put one copy in each of the CDNs. So it's super fast, right? A very smart way in which, CDN can be used here. What other services can we have for meeting, chat? Okay, we already explained how the meeting service is going to work, right? So analytics, right? Analytics. Now if the interviewer asks you, right, for what purpose do you think this, what will this analytics service analyze? What do you think?
Meeting time for each participants.
Could be, but there's also one thing that you can do, right? You can build OpenAI on top of it, right? uh, there's some features that you can provide on top of it. A is, you can record the meeting, and have that recorded meeting go to the meeting recording service. This is also something, if you think of it, right? There's a like lot of meetings that are being recorded, right? Service. So when you think of it, right, this meeting is getting recorded. It's gonna go through an encryption algorithm just like YouTube, and then it goes into the meeting recording service, right? Where it's basically again just a simple CDN game, right? So you can access those meetings, you can also download those meetings, right? And then eventually they move on to the central server, right? So meeting compression, meeting all those things that happen here, right? There's one more thing is, what you can do is this, you can build an OpenAI wrapper on top of it, where you are basically taking the meeting transcript, and you know so our devices, right, it needs to see at, let's say, 24 frames per second, right? But if you are sending to OpenAI for processing, that can be much lower, right? You can do like 4 or 5 frames per second. So instead of, a meeting that is recorded at 24 frames per second, you can break it down into like 6 frames per second, send it to OpenAI, and said, hey, this is the meeting that happened, can you summarize what type of meeting that is, and so that I can send that back to the user, right? So this meeting recording service could summarize that meeting and send it back to the user that, hey, this is the conclusion of the meeting, right? And it can also send it back to its own analytics service that this is the meeting that happened on my platform, what kind of insights can I derive from it, and also from my users, right? uh, Again, that's something, right? So this can be, when you think of, yeah, someone create captions, yeah, totally. Creating live captions on the call, right? Basically, how does that happen, right? When you think of it, you have this meeting service, and meetings are always being recorded, right? Let's say you have a small chunk that went to the server, it's immediately going to take that audio transcript, and it's going to pass it to OpenAI, and there's going to be, they have their own LLM models that are immediately going to create transcripts over these small chunks that are happening. uh, the the complication here is, how do you create it real time, right? Because if you send an audio stream, it needs to be decoded or something, so they take very small size chunks, and then they create those live captions, right? So this meeting recording service can also do that, like we can have something like a caption service for that. But yeah, okay, that's it. Chat service, analytics service. What else can you guys think of?
Ramit, why we need the summary of a meeting to be sent to the user?
Totally depends on the use case, right? Let's just say you are you are an SDR, right? Sales, you're selling a software product, right? And you just had a meeting with a client, and he did not close the product, right? So you need to send it now. You need to show that recording, or you cannot show a 1 hour recording to your CEO, right? It's a 1 hour. You cannot show 100-hour recordings that what went wrong, but the CEO can see the transcript and see that okay, this could be a red flag or something that the SDR said that she shouldn't have said, right? And even the SDR could get feedback from that meeting and understand. So there are multiple use cases, right, where you would want to you wouldn't want to go back through, like right now I'm doing this stream with you, but maybe you guys are not understanding some things, right? So if I get a transcript which says that okay, this is a part where you did not get good response, or if I get a transcript of the meeting, that helps me save having to go through that meeting again, right?
Okay, okay. So do we also store the meeting video in different pixel format like 720 or 420? Some.
Definitely. Yeah, when you think of it, right, different pixel formats. So what happens is that it passes through a compression algorithm, right? And that basically encodes that video into. So when you look at compression, the way this works is you have an image, right, like this one. And when a meeting is happening, right, what happens, you move your face like this left, like I'll open my camera so it's more apparent, right? So if you see this room that is happening, right, everything is constant across frames, right? Like I'm moving my face like this, I'm moving my face like this, right? Little movements are happening, but everything else is constant. So if you convert this, right, if you convert this into zeros and ones, right, this pink color, it's like it's a 12-bit value or something like that, right? So 90% of the meeting is basically constant, right? There's not a lot of variable happening, so it's possible to very much compress this thing, and that compressed format is basically being stored, right? So if it's, what's the difference between a 720p and a 360p? It's just how much more you are compressing, right? The more you compress beyond a certain point, you start losing that data, right? So it's, if even if you're saving it in 720p and you're sending a part of the 50% of the data, that's basically like a 360p video, right? Does that make sense?
Yes.
Yeah. So are there any questions? Like let's
Yeah, Haran.
yeah,
So you said there is large chunk of streams coming through, so that's why we use CDN, right?
yeah.
So does it mean like we maintain two connections, one for like getting the data and one for pushing, because we cannot push to CDN directly, so we have to push it to main server, right, directly, and to get we are using CDN. So does that works like that with two connections?
Your voice broke a lot. Can you just can you text it probably so I can understand better?
Yeah, is it clear now?
Yeah, yeah, it's clear.
Yeah, I was saying like as there is a lot of data coming, like there is a lot of streams, so that's why we use CDN, right?
Yeah.
Now, but we cannot push data to CDN. So does the client maintains two connections, one to get from CDN and other to the main server to push the data?
Um,
Is it like,
no, the
is it work?
client, the way this works is the CDN is also a server, right? So CDN is not managed by the person who is doing that, because there are millions of servers in the world, right? But CDN itself is a server. Let's say it's a managed service by some company, right? CDN has its own a lot of abilities, right? CDN is not just a platform for just pushing data. CDN provides a lot of abilities out of the box, data compression, data, all that stuff, right? So how it works is your client establishes a, I'll just mute you for a minute. Yeah. So your client establishes a connection with the CDN, right? This client, right? And the CDN also establishes a connection with the server, right? So you're pushing that data to CDN, and CDN is pushing it, or let's just say you're just pushing it directly to the server. Anything works, right? But when the data is coming back, it's going to the CDN, and then it's going to your server. That way the network load is also redistributed, like you have 100 people living in that area. So instead of those packets traveling all the way down to you, it can just travel to the CDN and then sit in the CDN, and then your devices are consuming that, right?
But number of like connections will still remain same, right, to the server? No.
Yeah, number of connections are same. So you either connect to the CDN or you connect to the server, right? So
But
node connection is not an issue here, right? You might actually get connected to both the CDN and the server, depending on, which one you are more comfy in sending information to, right? There are trade-offs in both. If you're sending to CDN to the server, sometimes it might be that you're dependent on the CDN a bit, right? But it takes some network load from the server, and CDN has better mechanism to redistribute that stream, right? So like you're transporting a package from here to um, Bangalore, right? If I'm transporting a package, so I would not myself board a train and send that package. So it's going to be a lot more effort. I would just put it to the nearest post box and they will send it through, right? So CDN provides that architecture to facilitate that.
Ramit, I have one more question.
Okay.
Suppose if I'm chatting from here to from somebody who is in Bombay and he is in suppose Bandra, and there are CDNs in local regions in Andheri, or you can say that Vasoga. So how the server will come to know which is the local nearest CDN of a user, and
Yeah.
how, because it has to identify the nearest CDN and then it has to push the data over there, right?
Definitely. So your computer is sending all that information to the server every minute, right? So that's why when you see Google Meet, right? If you see this right hand scene, see it uses your cookies and data, right? So here it has not asked for my permission, right? For my location permission, but some cases it does ask for your permission, right? And in other cases also it might actually just so again, every device has a different architecture, right? But in general, your computer or your which IP address you're routing it from, right? Through that it gets to know your approximate location, right? So Google Meet does not ask for my exact location, but it still knows my location, like which city I'm from my IP address.
Okay.
Does that make sense? Yeah. um okay, any more questions, or should we discuss something else? Like, is there anything else you guys want to discuss?
Uh, Ramit, we discussed that CDN was mainly used as a cache server, right?
Yeah.
And here, if we try to give like video stream, so won't it be like large amount of data per CDN, and then cost will increase?
No, actually, CDN is used to transmit large amount of data, right? Whenever you are sending videos or streams, right? Basically, the YouTube architecture, right? So what CDN does is, whenever you have this large amount of data that you are trying to send from A to B, instead of directly sending that data, you send it to the nearest CDN, right? And then CDN sends you the data. So CDN is basically that architecture that has it all built, right? Like if you're directly trying to send, maybe the failure rate might be higher, or it might not be that timely, right? Even data can transmit much faster between CDN to CDN. Yeah. But it's just a medium. Apart from CDN also, I would want you to focus a lot more on WebRTC, this P2P connection, and SFP, right? So these parts are more clearly understood, right?
Yeah, Ramit. So I have a question.
Okay.
Basically, said like in WebRTC, if connection increases, let's say more than 10, then it uses that other thing, SPP or something, you said, right?
SFP, yeah.
Yeah. So after that, it will perform same as like WebSockets like thing, right? Like everything is going to server and then coming from server. So then there is no P2P. So
Yeah.
that thing, then it will become similar to WebSocket, right?
Yeah, totally. So the reason SFP is done is basically so you can switch easily between P2P to SFP. WebSocket is an upgrade on top of HTTP, right? But the way this works is that so this is still P2P, right? This is still P2P, right? Initially, when there are two people, they are establishing a P2P between two, then P2P between three, and again between five to six. Then immediately the server comes into the picture, and then from P2P here to it goes to, so the connection is very easy to switch, right? And then again switch back if you're going down from a higher number of connections. So think in terms of the server, right? How easy it is for, like, there are Google Meets happening all the time, there are a million meets that are happening right now, right? 99% of those meets are happening between two people, three people, four people. So the server load is very low between those people when these Google Meet meetings are happening, right? uh, but if we were to use something like WebSocket, there would be a very high server load. So whenever this meeting goes to 100 people, it's very easy for it to switch back to something that can handle 100 people meeting, and then it goes down to that P2P. Again, when it goes to zero, right, then there's zero peer. So the server does not need to work that much, right? It does not need to terminate the connection or anything. It just sleeps. It becomes something dormant, right? Because there's no instruction to send. What the server does up to five people, it's just sending instructions, right? It's not even managing the video stream. Does that make sense?
Yeah. So does it mean like when connection is P2P or analytical and that caption service, everything won't work because server is not connected at that time? Like it is not handling video and everything at that time, right?
It is not handling video. It can be possible that the Google Meet is interpreting the video on the fly, and it's sending to the server. So when you look at WhatsApp, right, how does WhatsApp uh, interpret your chat, right? It's not supposed to interpret your chats. Occasionally you are still sending out messages. Okay, you're still sending backups to the server, right? And that backup is not encrypted. WhatsApp can get those data from that chat backup, even if it's your connection between WhatsApp one user to other user is P2P basically, right? So even if so they have their own ways of getting that data and generating the captions, right? So that if you were to think of the caption service as something a bit different than how the meeting service is working. The meeting service job is to optimize for meetings. Captions can be fetched in a lot of ways. Caption could be, it's like it's installing something, it's using Chrome inside, right? Whatever caption I am getting, it's interpreting it on the fly for me. Your caption could be completely different from my caption. That's also something that might be happening, right?
Okay, got it.
So Ramit, in SFP, we are going to server and then we are going to other users. So data is maybe persisted over there in server. But how about P2P? I mean peer to peer.
Peer to peer is basically connections that are established between user to user, right? So data is not persisted like that. Even in SFP, right? When even in SFP, I don't think they persist data. It's interpreting the data into a video feed and just sending it to people, right? So
But
persist.
how
Yeah.
in WhatsApp there is a backup chat, right?
Yeah.
So that is persisted, correct?
Yeah. So here also, like, if the system needs to take data from you, right, it doesn't it might take it from some other way, right now I'm communicating with you on this, what's on this Google Meet, and it's completely P2P right now, right? So my data is going to you, it's not touching the server, but maybe on the side there's a background job running, right, on the chat server that is encrypting this data. So on my device itself, Google Meet is encrypting some of this data and it's transmitting to the server, right? If I turn on captions or something, it's probably going to interpret that data on the fly, right? So data is being collected, but it's not like, you know, you're taking that one source of data and that's going into meeting service, also that's going into the caption service. Also caption service might collect its video in a very separate way, right?
Okay, okay.
Yeah, so maybe it's even extracting just the audio feed and collecting it, because the video does not make is not needed. And it's usually that's how things used to happen in older times, right? Even OpenAI did not support video feeds, so they just collected the audio, right? That's more significant and easier to compress. Yeah, so no other questions, right? Okay, I guess this was a great session, right?